If you love hurricanes, daiquiris, and, well, any rum cocktail, listen up. Captain Morgan's about to shake things up like never before. We're talking Bourbon Street, New Orleans, home to legendary drinks and unforgettable moments. But what if we told you the most iconic cocktails here have one thing in common? Hint, it's not bourbon. That's right, it's rum. And Captain Morgan is bringing unforgettable fun to Bourbon Street in a way you won't want to miss. Get ready for something big as we gear up for Super Bowl 59. Make sure to keep your eyes on NOLA's most iconic street. Who knows, Bourbon Street might just need a new name. Stay tuned for clues and get ready for the most legendary adventure yet. Please drink responsibly. Captain Morgan Original Spice Rum, 35% alcohol by volume. Captain Morgan Rum Company, New York, New York.
This is SpaceTime, Series 28, Episode 17, for broadcast on the 7th of February 2025. Coming up on SpaceTime, Io exhibits its most powerful volcanic activity so far, the dwarf planet Ceres and the building blocks of life, and new technology to search for distant Earth-like exoplanets in deep space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists with NASA's Juno mission have discovered the largest and most powerful volcanic hotspot ever seen on the Jovian moon Io. Even by the standards of Io, the most volcanically active world in the solar system, this new feature in the moon's southern hemisphere is extreme. The hotspot is not only larger than Earth's Lake Superior, it also belches out eruptions with 6 times the total energy output of all the world's power plants. The massive feature was detected by Juno's Jovian Infrared Auroral Mapper instrument. Juno principal investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says the find was made during the spacecraft's 2 really close flybys of Io as part of Juno's extended mission. Bolton says while each flyby provided evidence on this tormented moon that exceeded science expectations, the data from the latest, the most distant of the 2 flybys, really blew the team's minds. The source of Io's torment is the massive gravitational tidal interactions with its host planet Jupiter. About the size of the Earth's moon, Io orbits extremely close to the mammoth gas giant. At its elliptical orbit whips it around Jupiter every 42.5 hours. Now, as this distance varies, so does Jupiter's gravitational pull on Io, which leads to the tiny moon being relentlessly squeezed and stretched. The result, an immense amount of energy from frictional heating, and that melts portions of Io's interior, resulting in a seemingly endless series of volcanic plumes and ash venting into the atmosphere from an estimated 400 volcanoes that riddle its surface. Designed to capture the infrared light emerging from deep inside Jupiter, Juno's Jovian Infrared Auroral Mapper probes the gas giant's weather layer, peering some 50 to 70 kilometers below its cloud tops. But since NASA extended Juno's mission, the team have also been using the instrument to study the Galilean moons Io, Europa, Ganymede and Callisto. During its extended mission, Juno's trajectory passes very close to Io every other orbit, flying over the same part of the moon every time. Previously, the spacecraft made a series of close flybys of Io in December 2023 and February 2024, getting to within 1,500 kilometers of its surface. And this latest flyby took place on December the 27th, bringing the spacecraft to within about 74,400 kilometers of the moon, with its infrared instrument trained on Io's southern hemisphere. And while doing so, Juno detected an event of extreme infrared radiance, a massive hotspot so strong that it literally saturated the detector. Bolton and colleagues believe they actually detected a few closely spaced hotspots that all emitted at the same time, suggesting a vast subsurface magma chamber. The data supports that this is the most intense volcanic eruption ever detected on Io. The authors estimate that this as-yet unnamed feature spans about 100,000 square kilometres. Previous record holder was Io's Loki Patera, a lava lake of about 20,000 square kilometres. The total power value of the new hotspot's radiance measured well above 80 trillion watts. The feature was also captured by the mission's JunoCam invisible light. The authors then compared the JunoCam images from 2 previous Io flybys with those collected on December the 27th. And while these most recent images are of lower resolution since Juno was further away, the relative changes in the surface colouring around the newly discovered hotspot were still very clear. Such changes in Io's surface are known in the planetary science community to be associated with hotspots and volcanic activity. An eruption of this magnitude is likely to leave long-lived signatures. Other large eruptions on Io have created varying features, such as pyroclastic deposits composed of rock fragments spewed out by a volcano, small lava flows that may be fed by fissures, and volcanic plume deposits rich in sulfur and sulfur dioxide. Mission managers will use an upcoming, more distant flyby of Io on March the 3rd to look at the hotspot again and search for changes in the landscape. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, the dwarf planet Ceres and the building blocks of life, and new technology to search for distant Earth-like exoplanets in deep space. All that and more still to come on SpaceTime.
If you love hurricanes, daiquiris, and, well, any rum cocktail, listen up. Captain Morgan's about to shake things up like never before. We're talking Bourbon Street, New Orleans, home to legendary drinks and unforgettable moments. But what if we told you the most iconic cocktails here have one thing in common? Hint, it's not bourbon. That's right, it's rum. And Captain Morgan is bringing unforgettable fun to Bourbon Street in a way you won't want to miss. Get ready for something big as we gear up for Super Bowl 59. Make sure to keep your eyes on NOLA's most iconic street. Who knows, Bourbon Street might just need a new name. Stay tuned for clues and get ready for the most legendary adventure yet. Please drink responsibly. Captain Morgan Original Spice Rum, 35% alcohol by volume. Captain Morgan Rum Company, New York, New York.
Scientists are being faced with a new puzzle about the dwarf planet Ceres. A new study suggests that organic deposits discovered on the surface of this bizarre cryovolcanic world are unlikely to have originated from its interior. Organic molecules are among the necessary inventory of life-friendly worlds. On Earth, the compounds of carbon, hydrogen, and in smaller quantities other elements form the basic building blocks of all life. In recent years, scientists have found such molecules at great distances from the Sun, on trans-Neptunian objects, comets, and faraway asteroids. These bodies are thought to be largely unaltered remnants from the early days of the solar system, 4.6 billion years ago. The building blocks of life may therefore have been part of their basic configuration from the very beginning and possibly reached the inner solar system only later. Now, for the current study, the authors look for previously unknown deposits of organic material on the dwarf planet Ceres. With its location in the middle of the main asteroid belt between the orbits of Mars and Jupiter, this strange little world appears neither clearly native to the inner nor the outer solar system. Earlier studies have even suggested that this location may well be its birthplace. Scientists are therefore interested in the origins of Ceres' organic components. Did they originate locally in the asteroid belt, or did they arrive later? Evidence of deposits of organic material on Ceres were already found during the early stages of NASA's Dawn mission. The Dawn spacecraft reached Ceres in March 2015, remaining in orbit studying this unique world for about 3.5 years. During this time, its scientific camera system and spectrometer scanned the entire surface of the dwarf planet. Potential patches of organic material can be detected from the camera's data, and the brightness of the light reflected from these areas increases noticeably with increasing wavelength. Meanwhile, the spectrometer splits this light into many more wavelengths than the camera can, and therefore can identify the presence of any organics. Unfortunately, this remote data isn't sufficient to be able to identify individual types of molecules beyond reasonable doubt. However, scientists are certain that the discovered deposits consist of organic compounds that have a chain-like structure. Scientists refer to such molecules as aliphatic hydrocarbons. The authors of the study have now used artificial intelligence to comb through the entire surface of the dwarf planet looking for traces of aliphatic organic molecules. The study's lead author, Ranjan Sekar from the Max Planck Institute, says the sites of such organic molecules are actually quite rare on Ceres and devoid of any cryovolcanic signatures. The vast majority of deposits can be found along the edge or near the large aeronautic crater in the dwarf planet's northern hemisphere. Only 3 other deposits are located there, and 2 of these patches were not previously known. A closer look at the structures around the organic material's locations has failed to find any evidence of current or past volcanic or tectonic activity. There are no trenches, no canyons, no volcanic domes or vents, nothing. Nor were there any deep impact craters nearby. Now, during the Dawn mission, Ceres showed itself to be an extraordinarily cryovolcanic world. A watery brine is hidden under its surface, which in some places has been seeping out onto the surface until fairly recently. Now, it is possible that Ceres' unique cryovolcanism may have transported some organic material from the interior to the surface. But these new results simply aren't supporting that hypothesis. There's just no evidence for organic matter at the sites of cryovolcanic activity. And where organic compounds have been detected, there's no evidence of deep or surface activity. So the authors are suggesting that the impact of meteoroids from the outer asteroid belt probably introduced the organic material to Ceres. And computer simulations show that these bodies could frequently collide with Ceres. Now, importantly, since these nearby neighbours aren't picking up a lot of speed, only a small amount of heat would be generated by the impacts, and organic compounds could survive these temperatures. Unfortunately, Dawn didn't detect all types of organic compounds. It's just as likely that the building blocks of life could have been formed in Ceres' subsurface ocean, perhaps even reaching the surface. The authors would like to see a future lander mission to Ceres to detect the origins of any organic material. This is SpaceTime. Still to come, new technology to search for distant Earth-like exoplanets in deep space, and later in the science report, scientists carry out a survey of Tasmania's tallest trees. All that and more still to come on SpaceTime. Scientists and engineers are continuing their work building NASA's next big window on the cosmos, the Nancy Grace Roman Space Telescope. One of the key technology demonstration instruments, the Roman chronograph, has just arrived at NASA's Goddard Space Flight Center in Greenbelt, Maryland. There, it'll be incorporated into the new orbiting observatory. The Roman chronograph will help increase the variety of distant exoplanets, that is, planets orbiting other stars, that scientists will be able to directly image. It'll help pave the way in the search for habitable worlds outside our solar system by blocking out the glare of starlight that would otherwise hide an orbiting planet. The chronograph was shipped cross-country from where it was made at NASA's Jet Propulsion Laboratory in Pasadena, California. Once proven on Roman, similar technologies on a future mission could enable astronomers to use the chronograph to identify chemicals in an exoplanet's atmosphere, including ones that potentially indicate the presence of life. From other star systems, planet Earth would appear approximately 10 billion times dimmer than the Sun, and the two are relatively close together. So trying to directly image the Earth would be like trying to see a speck of bioluminescent algae next to a lighthouse from 5,000 kilometres away. Even with previous chronographic technologies, the glare from a masked star would still overwhelm an Earth-like planet. And that's where the Roman chronograph comes in. It'll demonstrate techniques that can remove more unwanted starlight than past space chronographs, and it does this by using several movable components. These moving parts will make it the first active chronograph in space. Its main tools are 2 deformable mirrors, each just 5 centimetres in diameter and backed by more than 2,000 tiny pistons that move up and down. These pistons work together to change the shape of the deformable mirrors so that they can compensate for unwanted stray light that spills around the edges of the masks. The deformable mirrors also help correct for imperfections in the Roman telescope's other optics. Although they're too small to affect Roman's other high-precision measurements, the imperfections can allow stray starlight in. And precise changes made to each deformable mirror's shape, imperceptible to the unaided eye, compensate for these imperfections. So far, more than 5,000 exoplanets have been discovered. Most have been detected indirectly, meaning their presence is inferred based on how they affect their parent star. Detecting these relative changes in the parent star is a lot easier than trying to see the signal from the much fainter planet. In fact, of the more than 5,000 exoplanets, fewer than 70 have been directly imaged. And those planets that have been directly imaged to date aren't like the Earth. Most are much bigger, a lot hotter, and typically much further from their host stars. Now, these features make them easier to detect, but it also means that they're far less hospitable for life as we know it. To look for potentially habitable worlds, scientists need to image planets that are not only billions of times dimmer than their stars, but also orbit their stars in the so-called habitable zone, the Goldilocks region, where it's not too hot and not too cold, but just right for liquid water to exist on a planet's surface. And what NASA learns from the Roman coronagraph will help blaze the path for future mirrors designed to directly image Earth-sized planets orbiting in the habitable zones of sun-like stars. This report from NASA TV.
Is there life out there? Are we alone? One NASA instrument will get us closer to finding answers to some of humanity's biggest questions. NASA's Nancy Grace Roman Space Telescope will fly with an instrument on board called the coronagraph that will allow scientists to see exoplanets, or worlds beyond our solar system, like never before.
So a coronagraph is a camera or an instrument that we use to look at planets around other stars. And the reason we need a special instrument to do this is because stars are so much brighter than planets. And what we need to do is we need to put something in front of the star to block the light from the star so that we can instead see the very faint light coming from the planet.
The Roman coronagraph, built at NASA's Jet Propulsion Lab, will take a giant leap forward in our ability to see worlds beyond our solar system, and will observe larger exoplanets, roughly the size of Jupiter. Testing the technology to see these planets is the stepping stone toward one day capturing direct images of Earth-like planets around sun-like stars. These technologies include different specially designed masks and self-flexing mirrors that will work together to block starlight, making planets orbiting these stars observable. Testing technologies that could enable future missions like NASA's Habitable Worlds Observatory mission concept.
And one of the primary goals for the Habitable Worlds Observatory will be to use a coronagraph using the technology that we demonstrate in the Roman coronagraph to look for signs of life around Earth-like planets orbiting sun-like stars. If we show that these technologies work together well, we will have demonstrated about 1,000 times better performance of a coronagraph in blocking starlight and allowing planet light to come through than any coronagraph ever built.
As it embarks on its journey to the stars aboard NASA's Nancy Grace Roman Space Telescope, the Roman coronagraph instrument will pave the way for future searches for habitable worlds and ultimately, the search for life beyond Earth.
And in that report from NASA TV, we heard from Roman coronagraph instrument technologist Vanessa Bailey and Roman coronagraph deputy project scientist Jason Rhodes. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims consuming a daily dose of omega-3 fatty acids may help your organs stay young. The findings, reported in the journal Nature, are based on clinical trials showing that consuming just 1 gram of omega-3 per day appears to slow down your rate of biological aging. Biological aging is the gradual process by which all cells, tissues and organs slowly but surely deteriorate. A new study has discovered that babies start to be able to sense smells at the age of just 4 weeks. A report in the journal J Neurosci scanned babies' brains as they were exposed to pleasant and unpleasant odours in order to see when the sense of smell first develops in infants. The authors found that at just 1 month of age, smells triggered activity in the smell detecting and sensory processing regions of babies' brains. The level of brain activity varied between odours, but unlike adults, different smells didn't trigger unique activity patterns in a baby's brain. However, measuring how deeply babies inhaled, the researchers found they inhaled more vigorously when the smells were nice than when they were nasty. Scientists have documented the tallest trees in Tasmania, including what the authors say is Australia's tallest known living tree, a 96-metre-high giant eucalypt called Centurion. Now, by comparison, the authors found the tallest known tree in Victoria to be 93 metres tall. In Western Australia, it was 78 metres high. The tallest tree in New South Wales was 71 metres high, and Queensland's Big Bob at 72.8 metres is the tallest tree in the Sunshine State. The authors say there were no known trees over 70 metres in height in South Australia, the Northern Territory, or the ACT. The researchers also discovered a tree with a trunk volume of 463 cubic metres, which they say is easily the largest known tree in Australia. The findings, reported in the Australian Journal of Biology, set out to document the tallest trees in Tasmania and found 6 species of eucalypts with trees that are either more than 70 metres tall or 11.5 metres in girth. These giant trees occur in a band between dry forests and temperate rainforests, and the researchers say they're vulnerable to fire, with 60% of the largest known trees already killed by fire since 2004. By the way, for the record, the world's tallest trees are the giant redwood sycamores of the Pacific Northwest, the biggest of which is the mighty Hyperion, which stands 116.07 metres in height. Out of all the way out there conspiracy theories, one of the easiest to disprove is the flat Earth theory. Forget pictures from space or ships sailing over the horizon at given distances. One group of flat earthers spent several $1,000s each just to sail to Antarctica to witness the 24-hour sun. In summer, due to the tilt of the Earth, the sun doesn't set much over the horizon. See, flat earthers have long maintained that Antarctica holds the key to proving the Earth is flat. In the flat Earth view of the world, Antarctica is actually an ice wall that encircles the other continents and holds in the oceans. Now, if the flat Earthers' view was correct, the sun would need to rise and set each day, even in Antarctica, and it could simply never circle the sky over 24 hours. But Tim Mendham from Australian Skeptics says, after seeing the sun fail to set, flat Earthers are now busy searching for ways to try and reconcile the 24-hour sun with their current flat Earth theories.
The interesting thing about flat Earthers is it's a lot of them, actually. It's a lot more than you think they should be.
One of the producers I worked with at the ABC during my more than quarter of a century at the organisation was a flat Earther, and you could not convince her that the Earth wasn't flat, no matter...
Yeah.
You know, and I said, NASA have checked, they've been in space, they've looked, it's definitely round. And how come all the other planets are round?
Government cover-up. The other ones are round, but ours are not.
This is an educated person who's a producer at a journalist at the ABC.
The thing you discover is that education has no bearing on belief in certain things. If people want to believe something, education goes out the window. Or they will fit it to the education. The thing with flat earthers, there's a lot more flat earthers than you think there are. If you talk to them, some of them are very sophisticated in their explanations for why the Earth is flat and why other people think it's round. They had to use the term the globe. That's wrong. One particular experiment, if you like, was by a pastor, believe it or not, from Colorado, who took a bunch of senior leading bloggers and on flat Earth, who were pro-flat Earth, down to Antarctica, because according to flat Earth the theory, Antarctica's on the rim, it's the big ice wall.
Governed by NASA, I believe. They're patrolling it.
Yeah, but it was the case that the sun does set and rise, as we see it every day, and that therefore on a flat Earth there should be no place on the Earth where the sun does not set, and they took them to Antarctica during the southern summers where the sun never sets. It dips down close to the horizon, but it doesn't actually set. And these flat earthers said, whoops, well, that negates the theory. But of course, like all these people and believers, they were soon finding reasons for why that might happen. And, this is only in this particular area. I don't know why they'd say that, and move them to any place in Antarctica or all the northern Arctic as well. And you'd see the same phenomenon. But like all believers, they will find an explanation. And some says, I don't think it falsifies a plane or Earth, P-L-A-N-E, Earth. I don't think it proves the globe. I think it's a singular data point. So they're out there, and like all people who believe in certain phenomena or conspiracy theories or whatever, it's very hard to convince them otherwise, even when you show them convincing evidence.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.